So section 6.5 talks about solving radical equations. Okay. One equation could be like a square root equation. For example, okay, first step would get rid of 3 through subtraction. Okay. And then recall from the last section, we were able to rewrite this, the left square root of 2x minus 3, as two x minus 3 raised to the 1/2 power. Okay. Now, I have to get rid of the 1/2. I have to get rid of this 1/2. So, what this chapter entails is to raise both sides by the reciprocal of the exponent given. So the reciprocal of 1/2 is 2. So in this case, I'm going to square both sides. So the square and the 1/2 will cancel each other out. Okay, and I'm left with, on the right, 25, because 5 squared is 5 times 5, which is 25. Then I'm just going to add 3. I'll have 2x equals 28, which is x equal 14, since you divide both sides by 2. Okay? So basically, in general, to solve any radical equations, raise both sides by the reciprocal. Okay, so in general, to solve any radical equation, you raise both sides by the reciprocal. Okay, so another example, okay, would be something like this. Okay, so first step, as always, divide by 3. Okay, we're going to rewrite the left 5th root of x plus 1 raised to the 3rd power as so this way it's better to see what reciprocal we need to raise both sides by if we change the radical expression to exponential. Okay, so we notice here that we need to raise both sides by 5 over 3, and we're left with x plus 1. And once you raise both sides by the reciprocal, you can rewrite it back into radical form. You don't have to, but you can. So going back over here, your x will equal 25. Now make sure the -1 is not inside the radical, because what you're doing is you're taking the radical and you're subtracting the whole thing by 1, not taking 25 divided by 3 raised to the 5th power and subtracting it by 1. Okay? Now there are some cases where you have something like this. Okay? All right, so you divide by 3. 4, you're going to raise both sides to the reciprocal, which is 3/2. 3/2. You'll have x plus 1 equals the square root of 4 cubed. Now, when you take an even root, whether it be a square root, a 4th root, or 6th root, recall how many solutions does the even root of a number have? And there's 2. There's a positive and negative. So when you're taking a square root or even a 4th root of some number, you're going to have a positive and negative answer. In this case, we're going to 4 cubed is 64. The square root of 64 is 8, so we're going to have positive and negative 8, which means we're going to have 2 x values. We're going to have a 7 and a negative 9. 7 coming from positive 8 minus 1, and negative 9 from negative 8 minus 1. Okay. When you have 2 solutions like these, make a note that you have to check for extraneous solutions, meaning that one of these x values is not a solution to the original problem. So I'm going to come down here. So one way to check for extraneous solutions is to plug in x values, okay, into the original problem, of course. So you'll have, so for the first x value, you'll have, let me extend the page a little bit. Extend the page. Take a minute on. Okay, like that. So let me just erase these 2 little things. So you'll have 3 times the 5th root. Oh, no, wrong one. Sorry. Whoop, whoop. You have 3 times 7 plus 1 raised to the 2/3 power equals 12. Okay, we know that this is 8. Okay, you're going to read this as 8 raised to 2/3. You can put that in your calculator as 8 caret, open parentheses, 2 divided by 3, close parentheses, or you can do the cube root of 8 squared. Okay, they both mean the same thing. So in your calculator, you can do that. It'll come out to 3 times 4, and 3 times 4 does equal 12. So that is correct. Okay, that is correct. Okay, now we're going to try the other x value. Do 3. I'm going to put it on the side here. Negative 9 plus 1. That's a negative 9. Plus 1. Raised to 2/3 power equals 12. Okay, this also comes out to 8, which we know is the same from the last one, so we know that 12 equals 12, and we're good. Okay? Now, the second way you can solve for extraneous solution is also by graphing. Where y1 is the 3 times x plus 1 raised to the 2/3, and y2 is your output, which is 12. And you would find the intersection. Okay. And I would put S in parentheses because you could have only one intersection, or you could have both x values be the intersections, okay? And you can go from there. So when you're graphing this and you actually see one intersection, find that intersection, list what it is, therefore you know the other x value is an extraneous solution because you know that the graph does not intersect with that output. Okay? So that is basically what 6.5 is. So you can try the homework tonight, look back on here, look through your book. They have really good examples in your book. And then also just let me know if you have any questions, and I will answer them for you. There isn't, but I do want to leave off with one more example. And there's an example like this. Okay, where since we know from 6.4 we cannot combine these radicals because they are not like radicals, what you could do is add both sides, okay, by the square root of x. So this is what I'm saying. And you'll get 1 plus the square root of x. And then to get rid of the radical on the left, you would square both sides. Okay, and you'll get 2x minus 1. This expression on the right is considered a binomial, so you're going to use the FOIL method. Okay, and I'll write that over there. Considered as a binomial. Oops. So use FOIL. Okay, and so this side becomes 1 plus 2 square roots of x plus x. Okay, all right. And then you can combine like terms this way by subtracting the x and subtracting the 1 to both sides. And you'll get, okay, so you'll get x minus 2 equals 2 square roots of x. Okay, you can you can divide or divide both sides by 2 and get 1/2 x minus 1 back equals that, but you'll have a binomial again. And I actually wrote this wrong. This is supposed to be addition, so my bad again. So therefore you don't get this line. Okay, you're actually supposed to get x equals 2 square roots of x. Okay. And then what you could do is square both sides, so you'll get x squared equals 4x, okay? Try to set it equal to 0, and then you can solve it that way and through this, and you'll get x equals 0. Oops. X equals 0 and 4, and then check for, since you have 2, check for extraneous solutions that way. Okay? There might be cases where you could, I can explain more tomorrow, and it may not show up on this quiz, and but it will show up on the next quiz. So be aware of that. I think it's the last few problems, if you want to take a look at that better. But I figured I should add that. So let me know if you have any questions. Email me and stuff, and I will get back to you guys with an answer. And then tomorrow we'll review problems from this section, from last section, from the other couple sections, so that way you have a good sense of what's going to be on the quiz, on the test on Thursday. Okay? Talk to you guys soon. Bye.